In the tower truss design, we're going to imagine having some kind of tower shape here made out of equilateral triangles that can support a load at the peak. So we can have designs like this, or we might have designs like this where the towers are more tower looking. And again, the idea is to apply some kind of force at the top joint and then try to design that truss so that it's as strong as possible. And what we can see when we look at the design is the kind of failure modes you're going to get are in tension and compression. And in this particular structure, the things that would fail immediately, or fail first rather, would be those three diagonal beams with the bottom vertical beam being strong almost at the edge of failure. What that leads us to is that the idea of redesigning the tower by just making minor adjustments to the structure and the location of the joints that might actually improve the strength of this without sacrificing any of the fundamental design criteria of how big and how tall it has to be. So this is where we get into optimization with MATLAB. You can see here that we're gradually increasing the actual load that this particular structure can support. And we can achieve that simply by nudging up and down the various joints in the structure. But we can also go further and move all the joints except for the tip and the base ones. We can't change the height. And we can see already that by shrinking some of the beams more dramatically, we can actually construct a much, much stronger design than we could originally. And this is going to be what you'll be exploring as part of the design challenges for the truss, for the tower truss.